Hello friends, my name is Tejendra Jangid. Here I am discussing the objective solution of P.S.Bimbhra from question number 21 to question number 30 for polyphase induction machine. Next video is coming soon for the synchronous machine, and coming soon solutions are power electrons for P.S.Bimbhra, EMFT Matthew and OSIDQ, electromagnetic SOMS outline series, signal system SOMS outline series, and many more. So don't forget to subscribe my channel, that is anybody can download education, that is ABCD education. Okay, now come to the question number 21. The variable resistance of the mechanical load in the equivalent circuit of the three-phase induction machine is given by, these are the option A, B, C, D. Now come to the solution. Okay, this is the equivalent circuit of the three-phase induction machine where P is the input power and this is the stator copper losses and this is the stator reactance offered by the stator winding. Okay, this is the core losses in the stator winding, and this is the magnetizing reactance which is denoted in the to transfer the magnetizing power, magnetizing flux. Okay, now the power transfer from the stator to rotor through air gap, that is known as air gap power. Now this power is I2 square R2 upon S. Now this, the component of R2 upon S is divided into two parts, that is R2 and this is R2 minus 1 minus S upon S. This denote the mechanical load and this denote the rotor copper loss. Okay, so the output mechanical load is denoted by R2 into 1 upon S minus 1. So the answer B is correct. Now come to the question number 22. If the omega is the synchronous speed in the mechanical radian per second, then the torque in the three-phase induction machine is given by. Now, come to the solution. We note that this is the air gap power which is transferred from stator to rotor through air gap. Okay, so now we know that power is power is equal to T omega S. Okay, now T equals to PAG, air gap power, divided by omega S. Okay, now power PAG is I2 square upon I2 square I2 square R2 divided by S. This value is put in this equation, and 3 is the multiplication due to the three phase induction machine. Okay, so due to three phase we multiply 3. Okay, now this is the torque developed, mechanical torque developed. Okay, so the answer is B, 3I2 square R2 S omega S. Okay, now come to the question number 23. If the stator impedance of the three phase induction machine is neglected, then the maximum torque, where V1 is the stator phase voltage, is given at. So the maximum torque, we find the maximum torque. These are the option. Now come to the solution. Now we know that T, the torque equals to V1 upon 3 upon omega S, V1 square divided by R2 upon S. This is the square. Okay, this is square. Now R2 upon S plus x2 dash square and multiplied by R2 upon S, that is the load. Now for the maximum torque, T dtt dt upon ds is equal to 0. So after that, equating solving this equation, we get the slip, maximum slip at the maximum torque. This is the slip at maximum torque is equal to R2 dash divided by x2. Okay, now from the equation 2, put the value of R2 in this equation 1. Okay, after that we get the maximum torque, that is equal to 3 omega s multiplied by v1 square divided by 2x2. That is answer is D. Correct answer is D. Now come to the question number 24. At low value of slip, the torque in the three-phase induction machine is given by, where V1 is the stator voltage. Now come to the solution. We know that this is the torque, 3 divided by omega s multiplied by V1 square upon R2 upon S square plus x2 dash square multiplied by R2s. Okay, so at low sleep region, the sleep is around 0.01 to 0.04. That is very low. Due to this part is very high, so x2 is neglected here. Now by neglecting that x2, we get v1 divided by R2 days multiplied by S2. So the torque is directly proportional to V1 square divided by X R2 multiplied by S. So the answer correct option is A. Now come to the question number 25. In three-phase slip ring induction machine TEM, that is maximum torque, SMT slip at maximum torque, and TEST starting torque, the following statements are made for this induction machine where the resistance is added. When the resistance is added in the rotor circuit, then these are the statement. Now come to the solution. Now in statement first, the TEM remain constant and SMT maximum slip at maximum torque is greater than 1. Now for this for the SMT, that is slip at maximum torque is greater than 1. Now this is like in this region. Okay, in this region the maximum torque is greater than starting torque. This is the starting torque. Okay, so the maximum torque is greater than starting torque, so the statement first is correct. Now come to the statement 2. The TEM, that maximum torque is remains constant. Yes, it is maximum torque is remains constant for the old resistance which are added in the rotor side. This this characteristic for the R1 resistance, this characteristic for the R2 resistance, and this characteristic for the R3 resistance, and this characteristics for the R2 resistance. Okay. Now, if now this is the SMT less than 1, so this is the region. In this region the starting torque is less than maximum torque. Yes, in this region this is the starting torque, okay, which is less than maximum torque, so it is also correct. Okay, now come to the statement number 3. The maximum torque remain constant. Yes, maximum torque remain constant at slip. Maximum slip at maximum torque is equal to 1. This is the slip. Okay, at this slip, the maximum torque and starting torque both are equal. So the statement third is also correct. Now come to the statement number 4. The where the maximum slip at the not maximum slip at maximum torque is greater than 1. This is the region. In this region, the starting torque is not greater than maximum torque. The maximum torque is greater than starting torque. So the statement 4 is wrong. So the statement 1, 2, 3 are correct. So the correct option is B. Now come to the question number 26. The three-phase induction motor with open slot have. Now come to the solution. Now this is the closed slot. Now if we use open slot, then the reluctance offered by the flux is increased. Here the reluctance is higher, so the if the reluctance is higher, then the x2 dash is reduced. Reactance offered by this flux is reduced. Okay, if the if the reactance is reduced, then the slip at maximum torque is increased, and maximum torque is also increased due to reduction in the x2. Okay, and starting current is also increased due to reduction in x2 dash. Okay, and now come to the statement number 1. The more starting torque, yes, more starting torque. Due to the starting current is higher, then the more is starting torque is also more. So the more starting current, yes, more starting current. And improve power factor. Now see the what is the power factor. Now if reluctance is increased, then the reluctance is increased, then reactance is decreased. Due to reduction in the reactance, the magnetizing current is increased. Due to increase in magnetizing current, the power factor 5.1 is increased 5 from 5.1 to 5.1 days. So the if the power factor angle is increased, then the cosine of this power factor angle is reduced. The power factor is worst, so the improved power factor is not correct. So the statement 1 is wrong. Now the statement 2. More starting torque, yes, more starting torque. More starting current, yes, worst power factor. So the statement 2 is correct. Now more starting torque in the statement third. More starting torque, yes, more breakdown torque. Tm is the breakdown torque, maximum torque is the breakdown torque. So yes, more is the breakdown torque. And improve power factor, no. Power factor is not improved, power factor is worst. So the statement third is wrong. And statement, now come to the statement number